Hello, this is our first dimensional analysis example. As we've learned in class that each time you read a word problem, you read it and pull out the information given and write it down. So our problem here says convert 6.24 centimeters to kilometers. Our information is that we have 6.24 centimeters and we want to convert it to kilometers. So we write down what we have, where we're starting, and where we're going, in this case kilometers. Then we develop our plan. So our first thing we want to do is always go to our central unit. In this case will be the meters. So our plan is to go from centimeters to meters and from meters to kilometers. So it's going to be a two-step plan. Every time we write an arrow, that means we have to add one step to our problem. In this case, we need our conversion factors. So we're going to consult our metric chart, since centimeters and kilometers are in metric, and we will find our conversion factors. Looking at the metric chart, we said that one of the easiest ways to read the chart is to put a 1 with the prefix and then put an equal sign and read the factor of 10 equivalent to our central unit. So in the center of our chart, which is equivalent to 1, we put our central unit. In this case, it's the meter. So we had 1 centimeter, and we were talking about kilometers, so we would have 1 kilometer. So to rewrite that, we would say 1 centimeter equals, we read across and find our factor of 10. In this case, it's 10 to the minus 2 of our central unit, the meter. So we have our first equivalent statement. Our second equivalent statement is the kilometer. So we put the 1 with the prefix, in this case kilometer, equals factor of 10, 10 to the positive 3 central unit meter. So two equivalent statements. 1 centimeter equals 10 to the minus second of a meter, and 1 kilometer equals 10 to the positive 3 meters. Now we're going to take those statements and put them back into our problem as conversion factors in that fractional form. So here's our problem. We have our 6.24 centimeters, and then we're going to multiply it by our conversion factors. We have centimeters, so we want to cancel out our centimeters, so we're going to put centimeter on the bottom, and then the other part of it, 10 to the minus 2 meter, on the top. This way, centimeters can cancel out centimeters. It's the same as saying 2 over 2. They cancel each other out. Same thing with our units. We cancel them out. So now we've canceled centimeters. We want to get rid of our unit of meter and end up with kilometer. So we're going to use our second statement that says 1 kilometer is equivalent to 10 to the positive 3 meters. This way meters over meters cancel, and we are left with our units of kilometers, which is where we're going, kilometers. All right, once all our units are set, then we can do our math. So one of the easiest ways is to multiply across the top, multiply across the bottom, and then do our division in the end. Here on the bottom we have 10 to the minus 3. So in order to divide, we would bring that exponent up and say 10 to the minus 2 minus 3 gives us 10 to the minus 5. Our original number is already in proper scientific notation, so we can just write 6.24 times 10 to the minus 5th of a kilometer. We've maintained the proper number of significant figures, in this case 3. We have our answer in proper scientific notation, 6.24, and we have our exponent times 10 to the minus 5th, and we also have our correct units. And that's the end for metric to metric conversions.